How can I determine if a representation is linear or exponential and write an equation? Um, so then a graph, it's usually pretty straightforward. I'm not going to spend much time in the video when you're looking at a graph. And then writing the equation, I'm not going to focus on that from the graph, but I am going to focus on looking at tables and a list of numbers. So if I'm given a table, and I want to look at seeing kind of like how it changes. So in this case, x increases by 5s, right? And f of x increases by 1,500. So what I have here is it has a common difference, or it's linear, and I might think, oh, maybe that's like an arithmetic sequence, right? But that doesn't lend itself always to writing a linear equation. To me, when I see this chart, I don't try to think arithmetic or geometric, think linear, and then think, oh wait, y equals mx plus b, or my slope-intercept form, because that's already kind of given to me. I already have my y-intercept in terms of f of x. So f of x, my y-intercept would be 1,500, right? And then my slope is the change in y, which is 1,500, over the change in x, which is 5. So 1,500 over 5 is 300. So f of x equals 300x plus 1,500. I don't have to necessarily think about like my term numbers or anything. So in this case, I don't worry about that. And I really just leave it like this. Use my slope-intercept form. You could even use point-slope form. You could try and use standard form. Whatever form you want. But I think slope-intercept's the easiest to write the equation. So I've written the equation for this based on this, and I've identified this as linear. Linear, right? Now, here's a table which I would identify as exponential. How do I identify this as an exponential equation? Well, I see that my x in terms of number of years goes 0, 1, 2, and then the value in this goes from 800 to 680 to 578. Well, there's no common difference. It's decreasing. It's actually decreasing, but if I multiply, it's a factor of 85 hundredths times 0.85. If I do 800 times 0.85, and I did this with a calculator, I get 680. And if I do 680 times 0.85, I get 578. How did I figure that out? Well, I just worked backwards. I did 578 divided by 680, and I got 0.85. And I did 680 divided by 800. I put that into a calculator, and I figured that out. I wrote that on here before I started this video. Now I want to come up with a function. Well, the key thing is to remember that in an exponential function, I'm going to use green. So in an exponential function, g of x equals a times r to the x. Well, this gives me the value for when x is 0. When x is 0, it's going to be g of 0 equals a times r to the 0. Well, that makes this 1. So really r to the 0 is 1. So a times 1, so g of 0 equals a. Well, guess what? G of 0 equals 800. So a is kind of like that initial value in this case. So g of x is going to equal 800 times r to the x. And r is the common ratio, which we could go through and substitute in values and figure out what r is, but we know that r is going to be your common ratio. So in this case, g of x equals 800 times 0.85, the number I'm multiplying each number by, to the x. And at that point, I can plug this in and I can test it out for the values, and it'll allow me to calculate future values. But I've used this to write the equation. I come up with my common ratio, and I use a 0 value to figure out what a would be, which if it didn't give this to me in the chart, if I could still plug in 0 and try to like work that out based on, no, I would have to have given me this in the chart. yeah, you'll always get that information. So that's kind of how you could work that out there. And then the other way, which for exponential functions, coming up with a geometric sequence is pretty easy in comparison to kind of working it out and thinking it through. Arithmetic sequences, I think slope-intercept form is probably a little bit easier to me, but this is your linear way. And this is going to always be in a situation where you're given a sequence. Note that I'm not given x and y values. I'm given a sequence here, right? So I'm given terms. So this could be my first, second, third, fourth. So these are what I would call like my n values. What I have to determine here is how is this changing? What's going on in the sequence? So 5 to 15, okay, I see that's plus 10, right? And then 15 to 25 is plus 10. So, okay, it looks like it's plus 10 here. So that's an arithmetic sequence. Whereas in the difference between my terms is 10. So now I could say a sub n equals, or this could even be written as f of x. I can write the same thing here. A sub 1, so my initial term, which is 5, plus, and I'm looking right here at this board down on the floor, plus the difference, so the common difference is 10 times n minus 1, so x, or this one would be n minus 1. And down here I could write x minus 1. And this will give me the value. For example, if I substitute in here n, let's say the first term, 1 minus 1 is 0, right? Okay, 0 times 10 is 0, plus 5 is 5. So that would work. Let's do f of x. F of x, where x is 1, the first term. All right? 1 minus 1 is 0. 0 times 10 is 0. 0 plus 5 is 0. Now 2. 2 minus 1 is 1. 1 times 10 is 10. 10 plus 5 is 15. And it would work out both cases. So you can write it either way here, and it will give you an equation, and you're identifying this as linear. And it's linear because I identified it as arithmetic. Arithmetic gives me a linear equation. Here's a geometric example. So we have 500, 124. I would work backwards and say, okay, so 20 times what equals 4, or 4 divided by 20. So, well, or 100 divided by 5 is 1/5, right? So it's 100 divided by 5 is 1/5. So that means I'm multiplying by 1/5 times 1/5. That works. 1/5 times 100 is 20, and 1/5 times 20 is 4. Now I go back here to this geometric, so I'm dealing with exponential. I'm going to have an exponential function. I've identified that. It's exponential, not linear. And I can write the equation as a sub n, or I could write it as f of x, just like I showed you with the linear one. A sub n equals a sub 1, so my first term is 500 times r, the common ratio is 1/5, to the n minus 1. And that's my equation. A sub n, I could write this in terms of x, like a function. F of x equals 500 times 1/5 to the x minus 1. So I could write that as an exponential function as well. So if I'm just given a sequence, I would use my arithmetic or geometric sequences. If I'm given like a table, I would try and convert it back into a function. But again, we're looking at how can I determine if a representation, like tables or sequences, is linear or exponential or linear, and write an equation. And that would be an equation, or this is an equation we can write.